Over 110 million tons of paper and cardboard are discarded every year in the United States, placing enormous pressure on waste management systems and natural resources. But here's the good news. Unlike plastic, cardboard can be reborn many times from discarded boxes. It can be collected, pulped, processed, and transformed into new sheets ready to serve the global supply chain once again. So how does this cycle of rebirth actually happen? Join the Factor inside one of the world's most advanced cardboard recycling plants and witness firsthand how boxes that seem destined for the trash are given a second life as brand new products. Benefits of recycling cardboard. Each ton of recycled cardboard does more than just turn into a new box. It carries immense environmental value. 17 trees are left standing in the forest. Nearly 26,500 liters of water are saved, and about 1 ton of CO2 emissions is avoided compared to making it from virgin wood. Even more remarkable is that its life cycle doesn't end quickly. A single sheet of cardboard can be reborn 5, even 7 times before the fibers become too short and weak to continue. And even then, it still isn't worthless. The remaining fibers can be repurposed into industrial paper, tissues, or other products that require less strength. Collecting used cardboard. Each cardboard box, once it has finished its job of protecting goods, begins a new journey, the journey back to the recycling plant. At the household level, boxes are usually flattened, tied into bundles, and set aside for collection. In supermarkets, shops, or warehouses where the volume is much larger, cartons are compressed by hydraulic balers into neat, square bales that are easier to stack and transport. Every day, thousands of these bundles leave their points of origin and head toward processing centers. When trucks loaded with cardboard arrive at the plant gates, the collection phase ends and the inspection stage begins. The bales are unloaded with forklifts or conveyor systems and moved into the receiving area. Here, each batch is weighed, recorded, and checked for moisture. Optical sensors, supported by human oversight, detect any remaining contaminants: plastic tape, metal staples, or stray nylon strings. Loads that are too damp or soiled with grease are separated to prevent an entire batch of recycled pulp from being spoiled. The bales that pass inspection are then sorted into categories: brown corrugated board, flat paperboard, or printed cartons. This careful classification determines what the recovered pulp will ultimately be used for in the recycling process. From the sorting area, approved bales of cardboard are sent straight to the hydropulper, the heart of the entire recycling process. Each bundle is dropped into a massive tank holding tens of thousands of liters of water, where the mixture is diluted to just 1 to 2% fiber, with the rest being water. This extreme dilution allows the cellulose fibers to separate quickly and disperse evenly, preparing them for the refining stage that follows. Giant rotor blades begin to spin, turning hundreds of revolutions per minute, generating powerful vortices. The turbulence is strong enough to break down the multi-layered structure of the carton, while also stripping away hardened glues clinging to its surfaces. At the same time, inks and thin plastic coatings are detached, either floating to the surface or carried off in the water, removing a significant portion of impurities. The result is a slurry of brownish pulp, rough but uniform, the initial foundation for a new life cycle. Yet this pulp must be further refined before it can become strong rolls of linerboard. Refining machines equipped with rotating discs and cutting bars repeatedly slice and fibrate the fiber surfaces. This process opens up countless microscopic fibrils, allowing fibers to bond more tightly during papermaking, thereby improving strength and durability. Alongside refining, the mill blends in a portion of virgin pulp produced directly from wood to compensate for recycled fibers that have shortened and weakened through multiple cycles. Depending on the final product, this ratio is adjusted. The outer liner layers often require more virgin fibers for smoothness and rigidity, while the corrugated medium inside can rely mostly on recycled stock. Additives such as starch, sizing agents, and wet strength resins are introduced, transforming the coarse slurry into a finished pulp, clean, consistent, and highly bondable. This becomes the essential feedstock for forming new sheets of paperboard. Once the refined and blended pulp mixture is ready, it is sent to the paper machine, the place where the liquid slurry takes on a defined sheet form. From large pipes, the diluted pulp flows down onto a moving wire mesh. In the footage, it appears like a stream of brownish slurry, almost like mud, but in reality, it holds millions of cellulose fibers, dispersing and preparing to bond together. As the slurry spreads across the wire, water begins to drain through thousands of tiny openings, leaving behind a thin layer of fibers that gradually interlace into a wet sheet of paper. Press rolls underneath continuously rotate, both removing moisture and pressing the fibers closer together. It is here, out of an unshaped liquid mixture, that the first sheets of paper begin to appear. In the next stage, the surface looks smoother and more uniform. This is the moment when much of the water has drained and the sheet has become strong enough to exist as a continuous web. Modern sensors monitor every detail: thickness, uniformity, and moisture content, ensuring that no edge tears or blotches interrupt production. Finally, the newborn sheet is guided through large press rollers once again, squeezing out the last remnants of water and flattening its surface. By the time it leaves the forming section, the paper web has taken on a clear structure, still damp, not yet strong, but ready to move forward to the massive drying section for completion. After the fresh sheet is formed in the forming section, it still holds a massive amount of water, more than half of its total weight. To become a durable material, the sheet must pass through pressing and drying. First, the wet paper web is guided into a press section made up of several pairs of giant steel rollers. The pressure from these rollers can reach hundreds of tons, squeezing the cellulose fibers tightly together and forcing out much of the remaining water. This stabilizes the sheet's thickness, smooths its surface, and compresses its internal structure. Sensors along the line constantly monitor the process, ensuring the web doesn't tear or wrinkle, even while moving at hundreds of feet per minute. Next, the sheet enters the dryer section, a system of dozens of enormous steel cylinders with polished surfaces, each heated by high-pressure steam to temperatures exceeding 300 degrees. As the sheet glides across each rotating drum, heat is transferred indirectly through the metal, evaporating the moisture gradually. Hot air is circulated continuously to keep temperature and humidity balanced inside the drying chamber. Thanks to this precise control, the moisture content of the sheet drops from over 50% to just 5 to 7% by the time it leaves the section. The process must be powerful enough to dry the sheet quickly, yet precise enough to avoid warping or brittleness. By the time it exits the dryers, the sheet is fully dry, with clear mechanical strength and a stable surface. Immediately, the broad paper web is fed into the reel section, where massive spools wound into rolls more than 10 feet in diameter and weighing several thousand pounds. These rolls not only make storage and transport easier, but also serve as the basic units for the next stages of corrugating and converting. The making of new cardboard. Once the massive linerboard rolls have completed pressing and drying, they are immediately sent to the stage that determines the strength of a cardboard box, corrugating. In this process, the paper web is fed between two grooved steel rollers rotating in opposite directions under high heat and pressure. As the paper passes, its flat surface is reshaped into a series of evenly spaced waves, either smooth sinusoidal curves or sharp V-shaped ridges, depending on the technical design. This corrugated structure dramatically increases vertical compression strength without adding extra weight. In this way, a thin, fragile sheet of paper is transformed into a sturdy core with impressive load-bearing capacity. Thanks to this technique, the dried rolls, fresh off the machines, become the essential building blocks of the modern packaging industry. Right after the paper has been shaped into uniform waves, it is guided directly into the lamination stage, the crucial step that transforms the corrugated core into a complete sheet of cardboard. Here, an automated gluing system applies a thin, precise line of hot adhesive on the crest of the flutes. Immediately afterward, a flat liner sheet is pressed firmly from below, followed by another liner applied on top.
The entire multi-layered structure then passes through large press rollers, where even pressure secures the positioning and strengthens the bond between the layers. The newly formed sheet continues through cooling fans and support rollers, allowing the glue to set while stabilizing its shape. By the time it exits the line, the result is strong, uniform sheets of 3-ply or 5-ply corrugated board, fully consolidated and ready for the next stages of converting. After the massive liner board sheets have fully laminated and cooled, they move on to the cutting and forming stage, the process that determines the final shape of a cardboard box.
That transforms flat material into three-dimensional box structures. Depending on packaging requirements, factories may run high-speed automated lines or rely on semi-manual systems tailored to specific orders. First, the carton sheets pass through rotary blades that slice vertical grooves, marking out the box flaps. Immediately afterward, the creasing section applies gentle pressure along these lines, creating fold marks that ensure the corrugated core bends cleanly without cracking. Every parameter, from groove spacing to crease depth, is programmed through software, precisely aligned with the original design. For boxes with more complex features such as handholds, air vents, flip-top lids, or rounded edges, the sheets are fed into die-cutting machines. Prefabricated metal dies with embedded blades, combined with pressure from rotary cylinders or flatbed presses, cut the entire box shape in a single stroke. Even intricate details like locking slots, cord holes, or angled joints are executed with precision during this stage. Once forming is complete, the carton blanks are neatly stacked and scanned by automatic sensors to ensure uniformity before advancing to the finishing area. When the carton sheets have been grooved and precisely shaped, they move on to the printing stage, a process that adds commercial value to the product. In many production lines, boxes require brand logos, barcodes, or handling instructions to meet packaging and distribution needs. Not every plant carries out this step directly. Much of the work is performed at facilities with integrated printing systems or specialized packaging workshops. Here, flexographic printers with soft cylinders are used to apply raised prints directly onto the carton surface. The entire process is controlled by automated systems, maintaining high-speed synchronization and precise accuracy. As each sheet passes through the rotating cylinders, an ink is evenly applied with the help of a doctor blade and pressed onto the paper surface under consistent pressure. Optical sensors constantly monitor sharpness, ink adhesion, and drying in real time. Once printing is complete, the surface is cured using UV lamps or forced hot air systems, allowing the ink to dry quickly and stabilize, readying the cartons for their final finishing steps. Right after the printing process is completed, the carton sheets move into quality control, the final checkpoint before leaving the production line. At this stage, specialized testing equipment measures compression strength both vertically and along the edges, ensuring that each box can retain its shape during stacking and transport. Meanwhile, automated sensors scan the surface to assess thickness, flatness, and overall uniformity. Any boxes that fail to meet technical standards are immediately rejected, guaranteeing consistency across the entire batch. The approved cartons are then directed into high-volume packing systems. Automatic folding machines flatten each box and stack them neatly into bundles with preset quantities. Depending on the order specifications, these bundles may be tied with straps, wrapped in shrink film, or packed into larger containers for easier shipping. Integrated weighing units and counting systems monitor every bundle in real time to ensure total accuracy. For large-scale orders, the cartons are stacked onto pallets, sealed with protective wrap, and tagged with identification codes to enable tracking and traceability. Through this process, every product leaving the factory is guaranteed to be high quality, securely packaged, and fully prepared for delivery to the end user. Conclusion: From the moment they leave households or supermarkets as waste cardboard boxes, WestRock embarks on a remarkable second life. They are collected, sorted, pulped, refined, and then passed through papermaking, corrugating, laminating, cutting, and printing. All of this unfolds on massive production lines where every cellulose fiber is reborn into a durable material that once again serves commerce, transportation, and millions of everyday needs. This journey not only showcases astonishing technical expertise, but also highlights the importance of sustainable thinking. Every ton of recycled cardboard means dozens of trees left standing in forests, tens of thousands of liters of water conserved, and tons of CO2 emissions reduced. Each box reborn is a small yet powerful step in easing the pressure on our planet's ecosystem. If this video gave you a fresh perspective, make sure to hit like, leave a comment to share your thoughts, and don't forget to subscribe to The Factorian for more fascinating stories about the world of industry and recycling.